Viewers, you are watching Mathematics channel number Collage. In this question, function f defined on R is a continuous function such that f0 is 1 and definite integral ft dt from 0 to pi by 3 is 0. We have to tell which of the following statements are true, which means there could be more than one options true. There are 4 options given. We have to verify each option for its correctness. We have to decide which option to start with. You can pause the video, try to solve this question yourself, and if necessary, you can unpause the video to watch the solution further. This denominator of the function in the option C looks familiar, whose limit can be calculated easily. So we will start with option C, which is limit as x tends to 0. We will divide numerator and denominator by x square. So x integral from 0 to x ft dt upon x square upon 1 minus e power x square upon x square. This will be limit in the numerator, limit as x tends to 0 of integral from 0 to x ft dt upon x upon limit x tends to 0 of minus e power x square minus 1 upon x square. The limit in the denominator will be minus 1 according to the standard limit. So what we are left with is only the limit in the numerator minus limit as x tends to 0 integral from 0 to x ft dt upon x. Now this limit is a 0 upon 0 indeterminate form which can be evaluated by L'Hopital's rule. But L'Hopital's rule demands finding derivatives of numerator and denominator. In the numerator there is definite integral and its derivative can be found out by a theorem known as Leibnitz Theorem, which allows derivatives of definite integrals. Let me explain for the benefit of those who do not know about Leibniz theorem. The theorem states that if function capital Fx is integral from variable gx to variable hx of ft dt, then d by dx of function capital Fx is, first we have to replace this t by this higher limit hx. So it will be f of hx into derivative of hx h dash x minus, we have to again replace this t by the lower limit gx. So this will be f of gx into derivative of gx g dash x. So by using Leibniz theorem, we will find derivative of this definite integral. So we write the limit as minus limit as x tends to 0. First we will replace this t by this higher limit x and write fx into derivative of higher limit x 1 minus, we have to replace this t by the lower limit 0. So f0 into derivative of the lower limit 0, 0. So this will be minus limit as x tends to 0 of fx, which will be minus f of 0, but value of f0 given in the question here, which is 1. So the value of the limit will be minus 1, same as here in the option C. Therefore, option C is true. Option D looks similar to option C. So next, let us verify option D for its correctness. We will write limit in the option D in the form of product of two limits, limit as x tends to 0, sin x upon x into limit as x tends to 0, integral from 0 to x ft dt upon x. Now this limit, as we know, is 1, and this limit from here, excluding this minus sign, is 1. So its value will be 1 and not minus 1 as given here. So therefore option D is false. Now let us check option A for its correctness. In option A, it is said that the equation fx minus 3 cos 3x equals 0 has at least one solution in the interval 0 to pi by 3, which means there is a function, say gx, for which g0 and g pi by 3 are equal and g dash x is 0. From the option g dash x will be equal to fx minus 3 cos 3x, which is already given to be 0. That reminds us of Rolle's theorem, which tells us that the values of the function, in our case say gx, at the endpoints of the interval, in our case 0 to pi by 3, are equal, which implies that there is a point within this interval where the slope of the function, that is slope of gx, is 0, provided gx is continuous and differentiable. That means g dash x is 0. Now, as referred earlier, g dash x is fx minus 3 cos 3x, which is equal to 0. From this, we can write gx equals integral from 0 to x ft dt minus sin 3x. Now, g dash x will be d by dx of integral from 0 to x ft dt minus d by dx of sin 3x. For finding derivative of this definite integral, we have to use Leibnitz Theorem. Accordingly, g dash x will be replacing this t by this higher limit fx into derivative of higher limit x, which is 1, minus lower limit 0 into derivative of lower limit derivative of 0, 0, minus d by dx of sin 3x will be 3 cos 3x. So g dash x will be fx minus 3 cos 3x, which in the option A is given to be 0. Now for the applicability of Rolle's theorem, we will find g0 and g pi by 3 using this relation of gx. So g0 will be integral from 0 to 0 ft dt minus sin 3 into 0, 0 will be 0, and g pi by 3 will be integral from 0 to pi by 3 ft dt minus sin 3 into pi by 3. Now the value of this integral is given in the question and it is 0, and cancelling this 3, sin pi is 0. So 0 minus 0 is 0. Now since g0 equals g pi by 3 and g dash x equals 0, proves that Rolle's theorem has been followed by option A. Hence, option A is true. Now we will find g0 from this relation integral from 0 to 0 ft dt plus cos 3 into 0 cos 0 plus 6 upon pi into 0, 0. That gives this definite integral is 0, cos 0 is 1 plus 0, that gives g0 equals 1. Next we find g pi by 3 integral from 0 to pi by 3 ft dt plus cos 3 into pi by 3 is cos pi plus 6 pi into pi by 3. Value of this definite integral is given in the question, which is 0 here. So g pi by 3 is 0 plus cos pi is minus 1. Cancelling this pi, 3 ones are 3 twos are plus 2, that gives 1. Therefore, all the three conditions of Rolle's theorem are followed. g0 equals g pi by 3 is 1 and g dash x is 0. Therefore, option B is also true. So in short, except option D, all the three options A, B and C are true. Viewers, if you like this video, please like, share and subscribe this channel, Number Collage. See you in the next video. Until then, keep watching Number Collage. Thank you.